Okay, honors geometry. Here is section 8.5, law of sines. So this is strictly for honors only. This is something you will touch more about on in pre-calculus, but trigonometry does not just fall under the right triangle category. You can extend trigonometry to non-right triangles, and we have these two laws, the law of sines in section 8.5 and the law of cosines in section 8.6, to then do these other types of problems. All right. So, first of all, when thinking about the law of sines, there are certain situations when the law of sines are used. So, first of all, your angle, 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 or your angle side angle situation. When you have this given to you, you are typically going to use the law of sines, and you're probably going to find a side length. Okay. The other instance is when you have the SSA case. When you're doing this, you're typically going to find an angle measure. Now, there is a little caveat with the SSA case. If you remember from our triangle congruence lesson, SSA was not a way to prove triangles congruent because there could be two triangles depending on the situation. So we like to call this the ambiguous case. The side angle. When you get to pre-calc, you'll investigate a little bit more. In this class, there is going to be one solid answer, so do not worry about that. But again, in these situations, you are going to use the law of sines. And here is the infamous law of sines. It says that the sine of A over A equals the sine of B over B equals the sine of C over C. The lowercase a, b, and c are just the opposite sides. So angle A, there's side A, and so on with B and C. Now, you only use two ratios at a time. And again, it depends on two ratios at a time. It depends on what you're given, right? Okay, so be aware of that. Now, we are going to derive this or prove this theorem on the next slide. Okay, so here is your generic triangle. And what we're going to do is we're going to draw a height down from C, an altitude, if you will, down from C to be a right angle down here and down here. And we're going to call it H. I'm going to use angle A and angle B to set up two sine equations using the right triangle on the left and the right triangle on the right. So the sine of A would be opposite H over hypotenuse B. And in the triangle on the right, the sine of B would equal opposite H over hypotenuse A. And I'm going to solve both of these for H by multiplying the ratio on the left by B on both sides. You get B sine of A equals H. And I'll do the same thing by multiplying by A in the equation on the right. And I get A sine of B equals H. And now, because each of these equals H, we can do a substitution. I can take this A sine of B and substitute it in for H right there. And we get B sine of A equals A sine of B. And now to make it look like the law of sines, here's a trick. I'm going to divide both sides by A and B at the same time. Over here, the B's cancel. There's sine of A over A. And over here, the A's cancel, and there's sine of B over B. And that is your law of sines. Now, again, I could do it again, draw a different height, and include angle C, and get more of the law of sines. Okay? So now let's do a couple problems involving the law of sines. I'm going to make two more videos, one for some generic problems and then one for some word problems.